Journeying into trigonometry. And we're going to first take a look at the Pythagorean Theorem and its converse here. Now, the Pythagorean Theorem is described as follows. A squared plus b squared equals c squared. And it's important that we define where c is. And c is the hypotenuse. And in right angle trigonometry, the hypotenuse is always opposite the right angle. So in this case, x is going to be c. And then these two adjacent angles to the right triangle, we might describe as A and B. And you could switch that around. It would not matter, depending on how we're going to solve it. So we're asked to find the missing measures. And so we can just simply substitute these values in and solve for C. What's this? And in this case, we're solving for what is the hypotenuse. So let's see, we'd have 17 squared plus 7 squared equals C squared. Now let's see what 17 squared is. I don't remember off the top of my head. 289. So we got 289 plus 49 equals c squared. And 289 plus 49 is equal to 338. That's c squared right there. 338 equals c squared. And to isolate the c, we're going to take the square root of 338 equals c. And I think this is going to be some kind of weird number. It's probably an irrational number. Let's see. Square root of 338. Yes, okay. Well, let's see if we can simplify this 338. Okay, it ends in 8, so it's an even number. Let's see if I try to divide it by 4. Well, that's not going to get it. If I try to divide it by 9, that's not going to get it. 5's not going to do it. 7. 7's not going to do it. 8, 9, 10, 11. 11's not going to make it. Let's try 13. Let's take, I was going by prime numbers, by the way. 338 divided by 13. That equals 26. That's 13 times 2. Okay. So then this is equal to the square root of, what's 13 squared? 169 times the square root of 2 equals c, which then equals, let's just double check, 169 times 2, 8 carrier 1, 12 plus 1 is 3, carrier 1, yeah. All right, and so this then is 13 times the square root of 2, simplifying that square root of 338. So this side length here, c then is 13 square root of 2. All right, let's look at this second problem that we have. And this time I want to identify where that hypotenuse is, because I'm using this Pythagorean theorem, and I see here that this 25, this side length of 25, is the hypotenuse. It's directly opposite the right angle. And so let's just give this A, let's give this B. And so I've got 22 squared plus B squared, or X squared, equals 25 squared. And I need my calculator again. 22 squared is 484 plus B squared equals 25 squared. I think is 625. It is 625. And why don't we subtract 484 from both sides? And so now we got b squared equals 141. And to isolate the b, we take the square root of both sides, and that leaves us with b square root of 141. And let's see, I wonder if I could simplify that. Well, we know 12 squared is 144, and 11 squared is 121, and 13 squared we saw was 169, and can't divide it by 9, which is 3 squared. I believe that's as simplified as it gets. B equals the square root of 141. Finding missing measures using the old great and wonderful Pythagorean theorem. A squared plus b squared equals c squared, where c is representing the hypotenuse when we're talking about right angle trigonometry.